Okay, the reason this lesson is going to be really short on day one of matrices is that you are going to have a top 20 test in class today because I knew this would be an easy lesson today. So it's about matrices. Data can be written any way you want. I can make a list of numbers, 2, 3, 5, 12. That's a list. Okay, but if you put the numbers into a matrix, as in you put a rectangle kind of around them, it's kind of like a big bracket, 2, 3, 5, 12, is just a way to arrange numbers. All right, so first thought is you can put any numbers you want in there, and you can make this any dimensions that you want. Like you could say, I'd rather have it have a couple more numbers. Now it's not a square anymore. Now it's a long rectangle. Or you can make it tall and skinny if you want to make your numbers 2, 3, 12, and 5. You want to write them this way? You can. All right, so how do you describe the difference between that and, let's say, that? They're both in a matrix. Well, each little individual piece is called an element of the matrix. And do you get that when you have things in rectangular arrangement that you got rows and columns? This one's easier to see it on. That way and that way, are those rows or columns? Those are rows. And try to remember this, or in fact, write this down. RC. You have to always do rows, then columns. We're going to keep coming back to this, and right now you might not see why it's that important. You could just say it backwards or forwards. It's important. You got to keep your rows and your columns straight, because sometimes we'll have you multiply this row by that column, and if you get them confused, it's really bad. All right, so would you agree then that this has 2 rows and 2 columns and is a 2 by 2, therefore? Does that make sense to you? It's a 2 by 2 matrix. So what's this? A what by what? 1 by 4 or 4 by 1. It makes a big difference. How many rows? 4. See, 1, 2, 3, 4. How many columns? 1 big column. It's a 4 by 1. It is not a 1 by 4. All right, here's another one that's similar. I'm just going to put dots this time so I don't have to write all these numbers out. That's a what by what matrix? 2 by 3. Rows, then columns. There's 3 columns, so 2 by 3. 2 by 3. Okay, for today, adding and subtracting matrices only works if they're the same. In other words, just think about it. It'd be really hard to add, let's say 2, 3 plus 1, 2, 3, 7. It's hard to know what to match up to make them add together, so they need to be the same. So for instance, now, have I got the same number of rows and columns in each matrix? Then it's pretty obvious which ones match with this one. That 2 matches up with this one, and the answer is going to be what? Plus 3. Not multiply, it's plus. So then 3 plus 2, there you go. That's all there is to adding matrices. That simple. Could I throw in a variable to make it more complicated, since after all you guys are in honors, higher algebra class? Of course we're going to do that. Let's say I have 3 and n and 1 and negative 2 all equaling 12 and 15. All right, who sees a problem here? Yes, sir. You don't know what n is one of the problems. There's another problem. It's TS. Because right now, the way I set it up, 3 plus the 1 does not equal 12. So something's wrong. All right? What if I told you that 1 was actually an I? Now is it possible? Okay. So now, do you get how you could solve for I? And what would I have to be? I must equal 9. And what would n have to be? Good, because 17 minus 2, or plus a minus 2, would equal 15. Good job, you're catching on fast. Now, next thing is we can scale them up. What do you think just happened to everything in the matrix? Multiplied by 2. That's all there is to it. So the answers are going to be 4, 8, 6, and 10. Okay? So could I do this and then subtract A, B, C, D? Yeah, except I don't know what A, B, C, and D are. But I could write what's called an expression for my answer. Okay, my answer would be a matrix. That would be a what by what matrix. 2 by 2, good. So my answer is going to be like this. And it needs something, 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 and something. But I don't know totally what they are. This one, though, I know has that, 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 and that in it. So, any guesses what I should write? 4 minus A. You got it. So in this spot right here, I could say that's 4 minus A. All right. What would this spot right here be? 6 minus C. Excellent. What you got there when you have a variable in your answer is called an expression. This is an algebraic expression that's within a matrix. All right, now, it's if you guys have caught on to that so fast, that shows this is going to be a really easy worksheet for you. Can you, just so you know, you can put data into a matrix that is super intense. And someday, they're going to have a matrix like this to express you. What'll it be? Your genome or your DNA. Now, I know what you're talking about. It's going to be more complicated than just a number, but there is the day coming very soon where you'll have all your data will be able to be fed into a computer, and it's just it could be in a matrix. They might not choose to use matrices for this, but they could. And your data then can tell them so much stuff. It's just amazing. Like they might be able to say, you are unfortunately prone to having a heart attack. Are you the one in the matrix? I get it. If you found out that you were prone to heart attacks, now some of you might say, I don't even want to know that because that sounds too scary and I might like change how I live my life. But on the other hand, what if you could like take all the advice from doctors then on things like, well, you're prone to heart attacks. Does that mean guarantee you're going to have a heart attack? No. It might, though, mean you better be more careful about, they just had some research that shows if you take a baby aspirin every day over the age of 50, that decreases your chance of heart attacks. So you might be like, hey, I'm 48, but I'm going to start taking a baby vitamin every day because that'll decrease my chance of a heart attack. And then you add to that all the other stuff that like, oh, and I should exercise more because I had less chance of heart attack. If you take that info and use it the right way, it could be pretty cool. If, heaven forbid, you were a woman who was prone to breast cancer and they were able to say, by our calculations, between age 30 and 35, you're likely to get breast cancer. Obviously, you could get screened a lot more often that way and then find out, oh, yep, I've got it. Because if they catch it early, they just have to take a tiny little, it's called a lumpectomy. Just a little piece of you has to be taken out and done, and then it's done. You might have had cancer, but it's all taken out and gone. You don't have to worry about it anymore. You wait too long, though, and their cancer can get out and be all over your body, and then you're kind of in trouble. My point is, data can go in a matrix, and it could be any kind of data. It could even be your DNA or your genome. And someday, right now, they can get a lot of info for about $1,000. You can go into your doctor and say, hey, I'd like to run a test for me. It costs about $1,000, which is a lot of money for you, but in the context of healthcare, like your parents are paying a lot of money for your health insurance and those kinds of things. $1,000 isn't completely unreasonable. And if they pay that $1,000, they might get info that's helpful for you already, but it's just going to get better and better. And pretty soon it'll just be like a finger prick and they'll be able to say, oh, yep, here's your results. And it'll be interesting to see how we use that as society. All right, so that right there on the board is a what by what matrix. 4 by 4. All right, now to make sure you know which one's which, now what is it? 4 by 3. 4 rows, 3 columns. See? So it's a 4 by 3 matrix. Okay, good. Now, what if I wanted to make it just a 2 by 2 matrix? Could I say, remember I can put anything in here I want. Could I say that these are the coordinates of points, like on a graph? Yeah, this could be the point 0, 0. That's the point 1, 1. Do you get how it would not be? Here's the point 0, 1, negative 2, 9. There's no point like that. You can actually do three-dimensional points. You can do an x and a y and a z-axis, but you don't have four-dimensional points because if there's a fourth dimension, we don't know what it is. That's an interesting topic for honors pre-calc, actually. We'll be talking about the fourth dimension. All right, 2, 5, negative 1, 7, and 9, 0. If you were to graph those 3 points, could you connect the dots? Sure, and what would it make? A triangle. Then what if I said, I want you to take those 2, 3, negative 1, 7, and 9, 0, and connect the dots and make the triangle, and then I want you to move the triangle to the right. Which ones would change, your x's or your y's? Your x's would change. Let's say I added 1 to all my x's. Now, a lot of people mess this up because of what we do with functions. Do you remember when we did stuff with functions and it was on the inside and we'd go like this, y equals x minus 3 squared, and you said, oh, that goes right 3? Do you remember that that's because it was on the inside of a parentheses, and so it's the opposite of what would normally happen? So don't think, oh, plus 1, that means move left 1. This isn't in a parentheses. This is just taking a point and adding 1 to its x. Let's say it was here. If I add 1 to the x, it moves it to the right. So it's the opposite of what you're used to. You're going to think that means left 1 because of what you're used to. But these aren't in parentheses that are squared, so you can trust them. It's more like the outside. Remember on these equations when I put like minus 7, you could always trust it. It meant down 7. Okay? These, you can kind of trust them. Plus 1 seems like it's to the right, and it is to the right. And I know you're really used to it the other way, so just be careful with that. Okay? So what if, here's a typical question. In fact, let's do a typical question. Let's go to your homework right now. Find matrices, day 1 worksheet. And I'll tell you which problems you can skip, and I'll do a couple with you. I'll pause when we get that right. All right, here's matrices, day 1 worksheet. And the first thing it says is name the coordinates of the vertices and draw the triangle. Do you get which ones must be the points? I hope you get, you can't have a point that way in this case, right? So, give me a point that I should graph. Negative 5, 3. Good. What's another point I should graph? 2, 0, and the last one, 4, negative 6. Graph those 3 points. It's as simple as it seems. Just good question. When in doubt, the first one you come to, we in our society read from left to right and from up to down. The first one you come to is the x. Okay? It's a good question because it is not clear. I could just say it's always the top row is x, but it really kind of depends on how they lay out the matrix, because what if it's like this? The first one you come to is the x. So this would be x in this case. Okay, so if you've got those graphed, 1, 2, 3, 4, 5, 3, and 2, 0, over 2, up 0, and over 4, up 6. You just have to connect the dots and you've got a triangle. Okay, now it wants you to, what matrix represents the image after a translation left? Yes. Oh, did I mess that up? It is a negative 6. My bad. Okay, try again. It was negative 5, 3. 1, 2, 3, 4, 5, 3. That one's okay, I think. Yep. And 2, 0 over 2, up 0. And 4, negative 6. It was just that last one. 2, 3. Thank you. Okay. Now they want me to take that thing and shift it left 3. Yes?
Over 4, down 6.
Didn't I just do over 4 and down 6? Did I go over 6 and down 4? Stop being right, please. Over 4, down 6. 1, 2, 3, 4, 5, 6. Am I correct now? All right, thank you. No, it does help, thank you, because if I only caught it way later, it would be harder to explain. Okay, so left 3 now. I take everything and move it left 3. Do I actually have to draw this new triangle? Doesn't say so yet, anyway. So all I have to do is make a new matrix. So here's a matrix. And remember, what's changing? The x's. So I'm not going to say -5, 2, and 4. I'm gonna write them, but I'm gonna do something to them all. Left 3. I feel like I should write +3. What should I actually write? -3. And then the y's, notice the height of my triangle is not going to change when I move it to the left. So that it's going to be 3, 0, -6. And that is how you would do that. I think you can handle it from there. The one I want to tell you about that's coming is the when you flip something over the line y equals x, that really messes with people. When I flip an equation across the line y equals x, that's called an inverse. And on inverses, this is something you learn in pre-calc. On inverses, everything that was x, what do you think? Becomes y. Everything that was y becomes x. Like, have you seen inverse on a computer screen? If you do inverse, it's everything that's light becomes dark, and everything that's dark becomes light. Okay, so inverse does that. It like reverses things. That's what inverse does. So x, if it was the point that, then the new point would be that. That's what inverse does. And what inverse is the reflection over the line y equals x. I'll show it to you. It's on that front page near the bottom, right there. Reflection across the line y equals x, that's called an inverse. And in that case, y becomes x and x becomes y. So you write a new matrix for this where the y's become the x's and the x's become the y's. Okay, so your next part is the part we already talked about, and I hope is really easy for you. Let's just like do the first one here. A. If I'm going to add these, do you get that the 3 goes with the 9 kind of logically? And what is 9 plus 3? So what's x equal to? 12. And 12 plus the -12, what do those guys make? 0. So therefore our y is 0. And lastly, you have the -8 and the 13. And I think you can handle it from there. Okay, now your assignment. I'm going to have you skip a few. You can skip B's and D's on these next 2 questions. So we're going to do A and do C. You can skip B and D. Same here. You can skip B and D. Skip B and D, skip B and D. And I'll also have you skip, you can skip C and D on this one, because A and B kind of go together pretty well here. So, okay, so that's skipping 6 of the questions. That's not too bad. On the last question this is the very last question on the worksheet, you skip C and D. Okay, I think that's a doable assignment. Now this is the part where we have a half hour left, but all we need is 20 minutes. So if you would please look at a top 20 for just a minute and find any kind of problem that you think you might be weak on, I'm willing to brush it up right now. This test does count in the 85% category. If you bomb it, I do have unlimited retakes on this thing all the way to the end of the quarter, okay? But I'd rather just have you get a good score the first time. Easier for you and me. So, is there any topics on the top 20 that you'd like to talk about? I guess this is not probably something I need to record because that's all we have for matrices for today.